This examination, CSE, main examination, chemistry optional paper I focuses primarily on physical chemistry, quantum mechanics, thermodynamics, electrochemistry, kinetics, and inorganic chemistry, chemical bonding, coordination compounds, main group and transition elements. Below is a curated selection of standard, high-yield questions modeled after recent UPSC mains patterns, complete with structured model answers. Section A, Physical Chemistry. Question 1. Quantum mechanics. Particle in a 1D box. A. A particle of mass m is confined to a one-dimensional box of length L with potential V, x equals 0 for 0, lr x, lr L and V, x equals infinity elsewhere. Derive the normalized wave function psi underscore n, x, and energy eigenvalues E underscore n. B. Calculate the probability of finding the particle in its ground state, n equals 1, between x equals 0 and x equals frac L, 4. Model answer. A. Derivation of wave function and energy, Schrödinger wave equation, inside the box, V equals 0, the time-independent Schrödinger equation is. General solution. Applying boundary conditions, at x equals 0, psi 0 equals 0, implies B equals 0. At x equals L, psi L equals 0. For a non-trivial solution, A, neco, sin, KL equals 0, implies KL equals n, pi, quad, n equals 1, 2, 3, dots. Energy eigenvalues, E underscore n. Normalization. B. Probability calculation, n equals 1, using the trigonometric identity, sin squared, theta equals, frac 1, cos 2, theta 2. Question 2. Chemical thermodynamics. Derive the Gibbs-Helmholtz equation relating free energy change, delta G, to temperature change at constant pressure. Explain how it is used to determine the enthalpy change, delta H, of an electrochemical cell. Model answer. Thermodynamic basis. By definition, Gibbs free energy is G equals H, Ts. In differential form, dG equals VdP, SdT. At constant pressure, dP equals 0. Substitution. Substituting S equals frac H, G, T into the partial derivative. Derivation of the standard form, differentiating the quantity left, frac G, T, right, with respect to T at constant P. For a finite process changing from state 1 to state 2, delta G equals G underscore 2 G underscore 1. Application to electrochemical cells. The electrical work done by a reversible cell is related to Gibbs free energy by delta G. Relation yields, where left, frac, partial E, partial T, right, P is the temperature coefficient of the cell's electromotive force, EMF. Question 3. Electrochemistry. Given the following standard reduction potentials at 25 carat, circ, text C, E carat, circ, text Cu, carat 3 plus, text Cu, carat plus, equals 1.28, text V. E carat, circ, text Cu, carat plus, text Cu, equals 0.52, text V. A. Determine E carat, circ, text cell, and the equilibrium constant K underscore EQ for the reaction. B. State whether, text Cu, carat plus is stable towards disproportionation along this pathway under standard conditions. Model answer. A. Calculation, half-cell reactions, oxidation, text Cu, carat plus, text AC, right arrow, text Cu, carat 3 plus, text AC, plus 2 E carat, quad, E carat, circ underscore, text ox, equals minus 1.28, text V. Reduction, 2, text Cu, carat plus, text AC, plus 2 E carat, right arrow 2, text Cu, text S, quad, E carat, circ underscore, text red, equals plus 0.52, text V. Standard cell potential, N equals 2. Equilibrium constant, K underscore EQ, using Nernst relation at 298, text K. B. Stability evaluation. Since E carat, circ underscore, text cell, less than 0, minus 0.76, text V, and delta G carat, circ equals NF E carat, circ greater than 0, disproportionation into, text Cu, carat 3 plus, and text Cu, is thermodynamically non-spontaneous under standard conditions. Therefore, text Cu, carat plus is stable against disproportionation into, text Cu, carat 3 plus, and text Cu, text S. Section B. Inorganic and coordination chemistry. Question 4. Crystal field theory and distortion. A. Calculate the crystal field stabilization energy, CFSE, for a d carat 6 transition metal ion in both high spin and low spin octahedral complexes. B. Using Yan-Teller theorem, explain why text CuH2 text O6 caret 2 plus exhibits tetragonal distortion while text CrH2 text O6 caret 3 plus maintains regular octahedral symmetry. Model answer. A CFSE calculation for D caret 6 octahedral complex. In an octahedral field, O_H, the d orbitals split into T, 2 grams, stabilized by minus 0.4, delta underscore O, and E underscore G, destabilized by plus 0.6, delta underscore O. Complex type. Electronic config. CFSE formula. Calculated CFSE. High spin, weak field, T, 2 grams, caret 4, E underscore G squared. 4 minus 0.4 plus 2 plus 0.6. Delta underscore O minus 0.4, delta underscore O. Low spin, strong field, T, 2 grams, caret 6, E underscore G caret O. 6 minus 0.4 plus 0 plus 0.6. Delta underscore O plus 2p. Minus 2.4, delta underscore O plus 2p. Note, P represents the electron pairing energy. B. Explanation of Yan-Teller distortion. The Yan-Teller theorem states that any nonlinear molecular system in an electronically degenerate ground state will undergo distortion to remove the degeneracy and lower its total energy. Text CuH2, text O6, caret 2 plus, text Cu, caret 2 plus, is a D caret 9 ion, configuration, T, 2 grams, caret 6, E underscore G cubed, D, Z squared, squared, D, X squared Y squared, caret 1 or D underscore Z squared, caret 1, D underscore X squared Y squared, squared. The E underscore G set is n-symmetrically occupied. Because E underscore G orbitals point directly along the ligand axis, an even electron density causes strong repulsive asymmetry. To relieve this degeneracy, the complex undergoes tetragonal elongation, D underscore 4H, symmetry, lengthening the two axial, text, CuO, bonds relative to the equatorial bonds. Text, CrH2, text, O6, caret 3 plus, text, Cr, caret 3 plus, is a D cubed ion, configuration, T, 2 grams, cubed, E underscore G caret 0. Both T, 2 grams, symmetrically half-filled with 1 electron each, and E underscore G, empty, orbitals are symmetrically occupied. No orbital degeneracy exists, hence, no Yan-Teller distortion occurs, preserving perfect O underscore H symmetry. Answer writing strategy for UPSC Chemistry Paper I. Parameter. Best practice. Derivations. Explicitly state boundary conditions, physical assumptions, and define all variables. Numericals. Show explicit steps, state standard values, e.g., F equals 96,485, text C per mole, and underline final answers with correct SI units. Diagrams. Draw clean mode diagrams, energy level splittings, or phase diagrams using labeled axes. To continue your UPSC chemistry preparation, solve numerical problems on chemical kinetics and reaction dynamics. Explore selected solved questions for Chemistry Paper 2, Organic Chemistry.